So this is going to be the last video that I do on inverse functions. And again, in this particular case, I want to talk very specifically about inverse trigonometric functions because I want you to be able to calculate things using trigonometric and inverse trigonometric functions. And the other thing I want to talk about is being able to compose trigonometric and inverse trigonometric functions. That's going to come in handy a lot in calculus, where we're not necessarily using a number all the time, but sometimes we're using x or some other variable. It's important before I really get far into this that we want to make sure that we're using radians in calculus. We don't really ever use degrees for the most part, just simply because radians are actually just a much nicer unit measure than degrees are. So before I get into this, just remember that 360 degrees is the same thing as 2 pi radians. Another way to remember this is 180 degrees is the same as 1 pi radians. Those are the two most common things to keep in mind. The other thing I want to go ahead and do is I want to talk about how to calculate, again, just with regular trigonometric functions. So most of these you can do either with a calculator or without a calculator. If you remember your unit circle, without a calculator is going to be able to work out pretty quickly, pretty nicely for most of these, and you'll get a lot of nice answers. Now, I will point out that, for example, tan of 0.5 and secant of 0.75, they're not unit circle ones, but pretty much all these others are. So if you want to do sine of pi over 3, I'm just going to type that in my calculator. I am going to make sure that I remind you to round appropriately. Um, Now, my calculator gives me an exact answer for most of these. So the rounded answer for sine of pi over 3 is 0.866. The exact answer is, again, the square root of 3 over 2. That comes from the unit circle. I'm not going to dive too deep into the unit circle today. It's not what I'm focusing on here. So I could also do cosine of pi over 6. Again, I could do the unit circle, and it would also give me the square root of 3 over 2, which is 0.866. Now, with this tan of 0.5, I cannot do the unit circle. That's not one of our angles on the unit circle. The answer that you get, you have to do this with the calculator, tangent of 0.5 is 0.546. And it keeps going. I'm just, again, rounding to 3 decimal places. I'm trying to round appropriately. Um, Now, the question that I get a lot of times with these others is cosecant, secant, cotangent. Well, there's not buttons for these in the calculator. So how do we do that? Well, the idea is to use those reciprocal or ratio identities that I talked about in the last video with these same I'm going to use the word argument, the same input. So cosecant goes with sine, so it's actually 1 over sine of pi. So if I try to type that in the calculator, I can even do just sine of pi in the calculator, which does give me 0. So this is 1 over 0. That's going to be an undefined answer. I will point out that sine and cosine, I know I mentioned this in the last video, sine and cosine are defined everywhere. No matter what number you plug in, you'll get out an answer. But the other four, tangent, cotangent, secant, cosecant, are not always defined. There are, of course, these instances where we get undefined. For secant, it's 1 over cosine of 0.75. And again, that's not one that we would know from our unit circle, so type it in. Um, let's see. If I type in cosine of 0.75, I get 0.732 if I round appropriately. So 1 divided by that answer gives me about 1.367, give or take. And the last one, and this is one I always have to be careful with, is I don't really ever do 1 over tangent of pi over 2. And there's a reason for that. And it actually comes through pretty nicely here in this situation. If I do tangent of pi over 2, it's undefined. But so we really don't know what 1 divided by undefined is. So instead of doing that, which is a terrible idea, do cosine of pi over 2 divided by sine of pi over 2. If you do that, let me type this in my calculator, cosine of pi over 2 divided by sine of pi over 2, you actually get the answer of 0. And so that's why, again, if I were to do this in my calculator with 1 over tangent, I would actually get a wrong answer. It wouldn't tell me what it was because it can't do undefined either. So when I write it as cosine and sine, I do get an answer at 0. And so that's the one I always go with, is I always do cosine over sine. Now, I'm going to move on and do the inverse trigonometric function. So all of these buttons are going to be kind of similar. Um, the only thing that's really different is you're going to either hit, depending on the calculator, you're either going to hit the shift button and then sine, cosine, or tangent, or you're going to hit the second button, depending on which calculator you've got. So for this first one, I'm hitting, my button is shift, sine, and then I'm going to type in 3 divided by 5, or 3 fraction 5, and then I'll close off the parentheses, and that gives me 0.644 radians. So my answers are going to be in radians on all of these. I'm going to do the same kind of idea for the next one. So shift cosine, and then I'll do 5 over 6, which will give me 0.586 radians. Now, this next one actually should have a pretty decent answer. Let's see, tangent, shift, then tangent of the square root of 3. And the answer that my calculator gives me is actually pi over 3 radians, which again would be one of those unit circle values, but yours might give you 1.047. They're the same thing. Now the question comes down to, again, how do I handle these differently since I don't have buttons for cosecant, secant, and cotangent? Well, if you notice when I did them before, I wasn't doing the inverse. So what I did was I took the whole trigonometric function and put it in the denominator. The difference here is that what I'm actually going to do is I'm not going to flip the output, I'm going to flip the input. So I'm going to do sine inverse of 1 over 2. I'm going to do cosine inverse of 1 over 5. I'm going to do tangent inverse of 1 over 0.5, or that's the number 2. So that's the difference here is, again, when I did this before, when I was doing regular trig functions, I flipped what the output was. I flipped the answer that I got. However, when I do inverse trig functions, I want to flip what I'm plugging in. So let me type this in. Shift sine of 1 over 2 gives me pi over 6, which is 0.524 radians. I'm going to do shift cosine of 1 over 5. Not going to be unit circle value, 1.369 radians. And the last one, tan inverse of 1 over 0.5, or again, you could do tan inverse of 2, which is 1.107 radians. Now, these last few are composition questions. Now, with these ones where I actually have a number, I could really and truly just type these straight up into the calculator and it should give me the correct answer. For example, I'm going to type this first one in. Shift cosine of 3 over 4, and I need to type the pi in as well, 3 over 4 pi, and making sure I have all that typed into my calculator. And my answer that the calculator gives me is 3 over 4 pi, or 3 pi over 4. Now, there's going to be something I mentioned to you in just a second when I do the next one is, since these are inverses, I'm going to use the word, quote unquote, cancel out. Now, trig functions are a little bit unique. As you saw in the last video, I kind of have to slim things down a little bit to make it work. So when I actually do the next one, shift sine of 3 over 4 pi, I want you to notice we don't actually get the same answer. We get 1 over 4 pi. Now, again, I want to make sure you guys are realizing I'm going to get decimals in some cases. So there's the first one, and there's the second one. But so the question becomes, why didn't I get the same answer? Why didn't these cancel out like they did in the first one? Well, the answer comes down to what the sine and cosine are taking in as their inputs and what they're putting out as their outputs. In this situation, um, the cosine function, again, when we talked about input versus output, we defined the range for cosine as 0 to 1, and we defined its input from 0 to pi. And so its inverse switched them, and so it took in 0 to 1 and spit out 0 to pi. However, when I do sine, we said its output is 0 to 1, but its input is negative pi over 2 to pi over 2. So when I do this, it spits out, sine of 3 pi over 4 spits out 0 to 1. Well, sine inverse is going to take that 0 to 1 and spit out some number between negative pi over 2 and pi over 2, which is pi over 4. So that's the thing you got to be careful of with some of these problems, is making sure the domains and ranges kind of match up. The last one I'm going to do is, again, I'm just going to type this into the calculator, and I want you guys to kind of see how this ends up a little differently. Tangent of cosine inverse of 4 over 5, it's going to give me 3/4. Now, you're probably asking me, where did those numbers come from? Well, it's kind of nice, in fact, with this one, because with this inverse problem, it's actually saying, hey, I know that cosine gives me 4 over 5, so cosine is adjacent over hypotenuse. There's the 4 and the 5. So the question is, what's tangent? The opposite over adjacent. So you do the Pythagorean theorem, you get 3 on this side, and you say, oh, well, tangent is opposite over adjacent, it's 3 over 4. So that's kind of actually the process I'm going to use on these next couple of problems. Is I'm going to actually use this idea of labeling a triangle and using the Pythagorean theorem and then rewriting it. So let's kind of work this out. So I've got sine of cosine inverse of x. So with cosine, this uses adjacent over hypotenuse. And what I'm saying is that's x over 1. So let me go ahead and draw a triangle real quick. And I'm saying the adjacent side is the x, and I'm saying the hypotenuse is the 1. If I use Pythagorean theorem, let's see, x squared plus b squared equals 1 squared. I'm going to subtract the x squared from both sides, which gives me 1 minus x squared, and then we'll square root. So that remaining side, the opposite side, is the square root of 1 minus x squared. So when I go to find sine, because that's ultimately what I want to look for, I'm going to use the opposite side over the hypotenuse. Well, the opposite side is this side over the hypotenuse, which is 1. So the correct answer here is the square root of 1 minus x squared. So make sure you draw your picture. Make sure you label it with the x and the 1. Make sure you do the Pythagorean theorem, and then find out what you're looking for. So if I'm looking for tangent inverse, remember, tangent is opposite over adjacent. I'm going to use x over 1. So x will be my opposite side. X is my opposite side, and adjacent is 1. In this situation, my Pythagorean theorem is going to be a little bit different because I'm looking for the hypotenuse. So we've got x squared plus 1 squared equals c squared. So I will square root that to find out what c is. And 1 squared is 1, so x squared plus 1 under square root. And so this hypotenuse is the square root of x squared plus 1. Now, I want to do secant. So it's important to remember that secant is the reciprocal of cosine. So cosine's adjacent over hypotenuse. So secant is hypotenuse over adjacent. So my hypotenuse, which is that side, over the adjacent, which is this side, is going to give me the square root of x squared plus 1 over 1, or just the square root of x squared plus 1. There's that final answer. And the question becomes, what happens if I flip it around? Do I kind of get the same answer, or do I get something different? Well, again, secant is going to use hypotenuse over adjacent, and I'm going to treat this as x over 1. So in this case, my x is going to be my hypotenuse, and my 1 is going to be my adjacent side. So now my triangle is all the way backwards from what I started with, and so we'll write it as 1 squared plus b squared equals x squared. I will subtract, so we'll have b squared equals x squared minus 1, and then I'll square root. So that's the square root of x squared minus 1. And when I want tangent, I need to do opposite over adjacent. So we'll take this opposite side over this adjacent side, and that should give me the square root of x squared minus 1. And that's going to be my final answer. Hopefully this does help kind of review or elaborate or at least help you guys better understand inverse trigonometric functions, how to calculate them, how to do all this stuff. Again, it is really kind of important for you to pay attention to things like, when I did trigonometric functions and I had to do one of these special ones, I had to flip my answer. Whereas when I did the inverse trigonometric functions, I had to flip what I was plugging in. And make sure, again, you are kind of following the idea for these other composition questions where I'm checking domain and range, or I'm, drawing a triangle and using Pythagorean theorem to find the remaining side. All right, have a great day. Bye.